Okay, so building out transformations that we did on Friday, we're going to be working with more of those functions. We're going to be talking about shifting left and right. We're going to be talking about vertical stretch and compression. Those are the things we're going to be working through today, all right? So this is just a review from the notes on Friday. So if A is greater than 1, it's going to be a vertical stretch. If A is between 0 and 1, meaning it's like a fraction, 1/2, 1/3, it's going to be a vertical compression. And if A is 1, that means you don't really see anything there. There's just a 1 in front of the parentheses or the radical or whatever. There's no stretch or shrink. Okay? When I say A is greater than 1, that top one. So if A is 2, okay, that means that our Y values are going to grow twice as fast. So if we think about an absolute value graph, okay, if we think about an absolute value graph, normally it goes up 1 over 1, up 1 over 1, up 1 over 1, right? Because that's how absolute value grows. Well, if I have an A value of 2, what's going to happen is this is going to be a steeper V. And it's going to go up 2 over 1, up 2 over 1. That's what's happening to it, okay? If it's less than 1, but greater than 0, so a fractional part, it's going to shrink it. It's going to compress it. So if we're thinking about the same graph and we had 1/2, it might look like this. Because now it's going to go up 1, but maybe it's over 2. Because that's 1/2. Up 1 over 2, up 1 over 2. Okay, so we're going to start with a cube graph first. So I know that a cubic graph, okay, its initial shape is going to look like this. Okay, now that's not perfect, but I know that 1 cubed is 1, right? So I'm actually going to shift this over a little bit because I know that it should go through here and here because -1 cubed is 1. All right, if we were to think about like -2, that should be going through 8. I can't say my drawing is perfect, but that's about what it should look like, okay? What we're going to do now is we're going to transform this with this equation right here. So first let's dive into what that means, okay? Is there any negatives up there? Do we have a negative in front of the 5? Nope. Okay, so that means that it's not going to be flipped. We're not going to have to reflect this over the x-axis. It's going to look just like that. We're just going to move it, okay? What about the 5? The 5 means we're going to stretch vertically, okay? So it's going to look skinnier, just like we talked about with the hair tie. It's going to look skinnier. And then the cube tells us that it's the cubic graph, and the 3 tells us that it's going to be shifted, okay? Do we have a K value up there? Nope, there's no K. Okay, remember our base form is f of x equals a, and in this case with cubes, it'd be x minus h cubed plus k. So there's no k right now. One thing I want you to add to your notes, highlight it, star it, make it big, okay, is that our vertex of a graph is always going to be -h comma k. So whether it's a cubic graph like this, a square root graph, absolute value graph, -hk is how you can find the vertex. All right, now let's figure out where the vertex is on this. So because we don't have a k value, our k is 1. What's my h? H value right here. Yeah, -3, because it's always opposite, right? Okay, we already know that that's opposite, so it's going to go -3, so left 3, and then it's not going to go up or down any. So my new vertex is going to be right here at -3. Okay, now this part of our question says label a point on each branch. So we already labeled our vertex, right? Now we need a point on each branch. What that means is it's on either side of our vertex. So to the left of the vertex and to the right of the vertex. So looking at this right here, what value is this right here? What x value is that? -3. 1, 2, 3, 4. Okay, and this one is what? Negative 1, 2. Okay, so those are values on either side of our vertex. So that's what we're going to use for our input-output chart, our table of values. Okay, so now I'm going to put a negative 4 in. Negative 4 right there. Okay, what we're going to do now is we're just going to plug negative 4 into our equation. I'm going to rewrite it over here so that we can see it, like right next to our table of values. And I'm going to put 5, and then instead of x, I'm going to put negative 4 plus 3 cubed. So if we plug that in there, what's negative 4 plus 3? Negative 1. Negative 1 cubed is negative 1. Negative 1 times 5 is negative 5. So I know that it's going to be at negative 4, negative 5. So let's go plot that on our graph. Negative 4, negative 1, 2, 3, 4, 5. Okay. Now on the other side we said is negative 2. So we're going to plug negative 2 in. We're going to do the same thing. So 5 times, but this time it's negative 2 plus 3 cubed. Negative 2 plus 3 is 1. 1 cubed is 3. Or 1 cubed is 1, excuse me. 1 times 5 is 5, right? Okay, negative 2 plus 3 is 1. 1 times 1 times 1 is 1. Times 5 is 5, right? Okay, so we're going to have 5 here. So we're going to go to negative 2, and then we're going to go up 5. 1, 2, 3, 4, 5. Okay, I want to show you something visually. Take your eyes and look at the board here. We took this graph and we just moved it to the left 4, right? Okay, if it did not have the 5, if it did not have this 5 right here, then our points would be where those black dots are. Okay, the effect that 5 has is that we stretched that black dot all the way up to where the red is and all the way down to where the red is. That's the effect that you can see when you lay it over like that. Okay, so now we know it looks like we can connect these with a straight line, right? But we know that because it's a cubic graph, it's not a straight line. So when we draw this in, we're going to have a little bend right there. Oop, that's not good. Little bend and a little bend. Good enough. Okay, it's not going to be a straight line. There's going to be a little curve before and after our vertex because I know it's a cubic graph. Do we understand what's happening with that 5 and how it's stretching it up higher? Okay. Here's the next one. Okay, we notice right now that has a squared on it, right? So what shape is this going to be? If it's x plus 1 squared, is it going to be a V, a U, a swoop, a wave? What's it going to be?
Parabola.
A parabola, a U shape. Okay, so my parent graph is going to look like, oops, not good. Still not good. Try that way. There we go. Something like that, right? 1 squared is 1, 2 squared is 4, and so on. But it should look like that. Okay, now we're going to see what happens when we translate this. So first, let's find our vertex. So it's x plus 1. So that's going to be what? Minus 1. And then is it up or down 2? Down 2. So negative 1, down 2. That's going to be my vertex right there. Now we want to go on either side of that. So I've got this right here and this right here that I want to use on either side of my vertex. So we're going to use negative 2 and 0. So let's create our table of values when x is negative 2. Well, negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times negative 1/2 is negative 1/2. Negative 1/2 minus 2 is negative 2.5. So go left 2 and then down 2.5. So it's going to be relatively close to that one. Now we're going to do the 0 because that's on the other side. If we do it right, it should be mirrored. So 0 plus 1 is 1, squared is 1, times negative 1/2, negative, yep, we get the same thing. Negative 2.5. Okay? If that doesn't satisfy you having those like really little ones, if you want to do another one, we could. We could just go to the next marking. So it would be negative 3, right, which actually works pretty well on this one. So negative 3 plus 1 is negative 2. Negative 2 squared is positive 4. Positive 4 times negative 1/2 is negative 2. Negative 2 minus 2 is negative 4. So if we did put that one on there, it'd be at negative 3, negative 4. And then the other one on the positive 1 would be mirrored. So what we can see is that it's opening up wider, or the graph in other terms is fatter than our parent graph. Okay, the graph f of x, and this is a cube root graph. So I know that a cube root, the graph is going to be that wave. Like that. All right, again, like that. I know that 1 cubed is 1, and negative 1 cubed is negative 1, so it should, like in general, go about through those 2 points. Okay. Now, let's find our vertex. So in this case, negative h is going to give me a positive 4. So right 4 and then up 1. So that's going to be where my vertex is now. And then 1 on each branch. So we go to the left and to the right. Well, left of that is going to be positive 3. And to the right of that is going to be positive 5. Okay. Are we going to have vertical stretch here? Yes, we have some big time vertical stretch because we have the 5. Okay, so it's going to end up being a lot long, like taller. Okay, so we're going to plug a 3 in there. 3 minus 4 is a negative 1. I can do negatives, right? With cube roots, we can have a negative inside the radical. So negative 1, the cube root of negative 1 is negative 1. Negative 1 times 5 is negative 5 plus 1 is negative 4. So I'm going to go 3, negative 4. Over 3, down 4. 1, 2, 3, 4. So it would be about right there. Okay, you can see the distance right here. The distance between these two like this compared to this already is stretched by quite a bit, right? That's because of that 5. Okay, now let's do our 5. 5 minus 4 is 1. 1 cubed is 1 times 5 is 5 plus 1 is 6. So we're going to go over to 5 up to 6. Okay, now again, we know that it's not a straight line because it's a cube root function. So it should come down over, it's not very good. There we go. About like that. You can see on this one the impact that that 5 has on our points. It should really, from our vertex, if it was the parent function, just go over 1, up 1, because 1 cubed is 1. But it goes all the way up because it's times 5. The only thing that's different, and I'm going to use the same exact graph, but I'm going to just erase these 3's. The same exact equation, excuse me, function. Now what is it? Instead of a cube root function, it's what? A square root function. What do we know about square roots? Like for the cube root, this was fine, right? Is that going to be fine like that? No, I can't have that. Hey, remember the parent function for a square root? It starts at the origin and then swoops away, right? Why doesn't it go to the left at all? Yeah, we can't have a negative in there, okay? So that's going to be the same case here. So this one's still going to be shifted the same way, right 4, up 1. So our new graph is going to be right 4, 1, 2, 3, 4, up 1. That's going to be our new vertex. So instead of it being at the origin, it's at that red dot, okay? And then it's also going to be stretched 5, okay? But for this one, because we know we can't have a negative, like if I go and I put 3 in there, that's going to be the square root of 3 minus 4 times 5 plus 1. Well, can I have negative 1 in there? I can't do that. Okay, so this goes back to Carson's question. Hey, this is the one where you cannot pick a number on each side of the vertex. If it's a square root function, we're just going to pick 2 on the right. Okay, so for this one, I would pick positive 5 and positive 6. So 5 minus 4 is 1. Square root of 1 is 1, times 5 is 5, plus 1 is 6. So it's going to be over there and then up to 6. 1, 2, 3, 4, 5, 6. Way up there because we have that times 5. Okay, for my 6, if I put 6 in there, it's going to give me a weird number, right? Because I'm going to have 6 minus 2. The square root of 2 is some weird number, right? Times 5 plus 1 is going to be like a decimal. That's why it can be helpful to try to achieve inside the radical square numbers. So like we already got the 1. We already have the 1 for 0. So the next one would be 4. So 8 minus 4 is 4, right? So if I plugged 8 in. So instead of 6, let's plug 8 in. 8 minus 4 is 4. Square root of 4 is what? 2. 2 times 5 is 10 plus 1 is 11. My graph doesn't go to 11. Okay? So that might not always work out, but it can be helpful to do that. So this one is going to go like this. Just a bigger wave. Carson.